Today, we're going to add lights to our scene, but these won't be typical lights. Instead, we will create the lights inside our objects. This technique can be used to add a bit of drama to the scene, and I think it looks pretty neat. Okay, let's get started. In the previous video, we added materials to these objects based on the object's type. We have the green spheres, the yellow cylinders, the red cones, and the blue cubes. The materials are glossy and they reflect the environment, as you can see. If you haven't seen that video yet, you can check it out here. I'll also add a link in the description. So, our objects look pretty great with the new colors, but adding some lights is going to add a lot of interest to the scene. Okay, the first thing we want to do is change the way that the viewport looks. We go up here to the settings, and in the lighting in particular, we want to change the scene lights. We're going to enable that, and the scene world, we're going to enable that. And what this will do is it allows us to see only the lights in the environment that are contained in the scene. We can do the same thing over here in the rendered view, scene lights and scene world. And now we're ready to go on to the next step. Okay, one more thing we want to do is change our render engine to Eevee. That's going to render everything much faster while we're in development. And down here, let's enable the screen space reflections. And you can see now the reflections of the other objects in the material. We can turn that off and turn it back on. So that'll help us to develop the script a little bit faster without waiting for cycles to render the scene every time. Okay, so I've opened up the scripting workspace, and quickly before we get started, I'd like to change the way that I'm deleting objects each time the script is run. Previously, we were using the BPY ops interface, as you can see here, and what I'd like to do is update that to use the data interface. So let me delete this. I'm just going to briefly paste in what I had done already. And we can see here the way this works is it's going to get a list of objects if they are mesh or light type objects. We're going to print those out, although that was just for debugging. So let me just go ahead and comment that out. Then for every one of those objects, it's going to call the BPY data objects remove function and setting do unlink to true. So it's going to unlink those as well. The next thing we want to do is take the meshes, the materials, and the lights. So for every mesh in BPY data meshes, for every material in BPY data materials, and for every light in BPY data lights, we're going to do the exact same thing, create the list of those objects, iterate the list, and then call the remove function. Then the very first thing we do in our script is call our new updated clear created data function, and everything should disappear. Okay, let's test that new function that we created to delete everything. First thing we can do is go down here, just going to highlight everything, control / to comment it out. Now when I run this script, it should just get rid of everything that's there. And yeah, we can see it looks pretty good. All the objects are gone. So let's uncomment everything that we just commented out, and we can go ahead and move forward. So what we'd like to do is add a light inside some random subset of these objects. Then those lights are going to have a glow and illuminate the scene. It's going to look pretty cool. So let's start with a function, and we're going to call this add lights inside some objects. And we'd like to have a parameter here for the probability of any individual object getting a light inside of it. So we'll call that light probability. And we gave that a default value of 1.0 so that if you don't pass in an argument, all of the objects will get a light inside. So the first thing we want to do is get a list of all of the mesh objects, and we can do that with a list comprehension. So we're going to take every item in bpy.data.objects, and if the object type is mesh, we're going to return that in our list comprehension and add that to our mesh objects variable. So the next step is to iterate over the mesh object. So we can do that like this. So for each one of these objects, let's check to see if we want to add a light inside of it. And the way we're going to do that is first we're going to get a random number between 0 and 1 and determine if that number is less than the light probability argument that we passed. So if the random number is less than the light probability, we're going to go ahead and create that new light. So we create this light by using the bpy.data interface. And we create a new light, set its name to point light, and set its type to be point. And as a reminder, we can always use the tab interface down here in the console. So if we know it's something in the bpy data interface, we can say bpy.data. And we can hit the tab. Let me actually just make this a little bit bigger so we can see what's going on here. And then as we can see, we have lights here. Okay, so that makes sense. bpy.data.lights. And we know we're going to add a new light. And there we go. We can see the argument's name and type. So that actually is a quick way to find out what the correct interface call is to create a new object or a new type of light or mesh or anything else you're looking for. So for example, we could create one with a name of new light. Actually, let's remove the space and a type of point. So we can see that the new light has been created over here under the lights category. Now that we created the light, let's set the energy or the output of the light. Okay, so here we set the light energy to 100, and later on I can show you where that value gets set in the user interface, and if you'd like to set that to something different, it's easy to change it right here in the code. So the next step is to create an object for the light, and we're going to set the light as the object's data. The way that we can create the light is again using the BPY data interface. So we'll do it as follows. So it's important to make sure to pass the object data parameter and set it equal to the light that we created above. So here we set the object data equal to light. Okay, so now we actually have the light object and we can add it to the scene. The way we add the object to the scene is using the BPY context interface. Okay, so that should be everything we need to add lights inside some subset of the objects. So let's go ahead and add this function down at the bottom, or add a call to the function down at the bottom. All right, so we'll go ahead and call that function and let's run the script. All right, so we have an error, but I wanted to go ahead and show you that so we can see how to solve it. Looks like the name random is not defined. So the reason that you would get an error like that in general is because you haven't imported something at the top of your script. So if we go up here to the top, we can just import random, and that should solve the problem. All right, so it looks like the script ran without any problems, but I don't see any lights. We've created the lights, you can see them here. And let's see if we have any light objects. Yep, we have the light objects. So what's going on? Let's go over here to the layout window. And we're going to check in wireframe mode. Yep, we definitely have a problem. So I did a little troubleshooting and I realized what the problem was. So if we go over here, we can select different objects and see them highlighted. But if we select the lights, we'll notice they are all in exactly the same place. So the lights are here. It's just that they're all in the same place. So if we move this light, we can see it's there. So they're all on top of each other. So let's go ahead back to the scripting tab and we're going to fix that. So what happened is we set the light, we set the object, we linked everything together, but we forgot to set the location of the object. So what we're going to do is set the location of the light object to be the same as the location of the mesh object. And actually, if we go over here in the viewport, we can see there's some light coming out from the ones that we moved, so we can actually see them now. So let's go ahead and run the script again and see what happens. All right, so I still don't see any light. Let's go back here and see what's going on. Okay, so this looks better. I can see a light inside each of the objects. So we can see the lights here, here, and here. But the problem is the material is not transparent, and so we can't see any of the illumination from the lights. So the next step is to fix that problem. All right, let's go ahead and create a function to make a translucent material. Earlier we had done a reflective material, so we'll use the template here and do about the same thing. We'll pass in the material name as an argument, but we don't need to set the color. I think I'm just going to set the color of all of the materials to be the same. So the first step is going to be exactly the same as we did up here in create reflective material. And actually the next thing is going to be the same as well. So we're going to say use nodes equals true. Now here's where the difference is coming in. Instead of using the principled BSDF shader, we're actually going to use a different type of node called a BSDF translucent node. And I can show you a quick example of that. Let's choose an object and set its material to be translucent. So we'll grab this cube here, go to the shading workspace, and if we look here, by default, we have a principled BSDF material, and this is the one we set up in our previous video. So let's get rid of that. And let's add a new shader, and it's going to be translucent. And then we're going to add a new material output, and we're going to connect these together. And now what we can see is all of the cubes have this translucent material, and we can even like pick an interesting color if we want, something like that. So that's how you would set the material to be translucent. So let's go ahead and go back into the scripting interface and do the same thing in Python. So now you can even see that some of these cubes have lights inside and they're showing through the material now. So this is great. So the first thing we're going to do is create that translucent shader. So we can use the node tree interface to create a new node of this type, shader node BSDF translucent. Oh, and one thing we want to do before we get started here is clear out all of the default nodes that are going to be created when we added that material. So let's do that here. I'm going to go ahead and paste in the link to the documentation for this shader node as well. So you can take a look at that if you want more information. Now, the next thing we want to do after we create the shader is to set the color. So let's go ahead and do that. So this color can be anything you like. I happen to experiment on my own with the shader interface and picked out a color that I thought looked good. So we're just going to go ahead and hard code that in here. And again, as a reminder, we can use this tab completion to check it out and see what the available options are. Okay, so as you remember from the shading example over here, we had to also create a material output and then link them together. So let's do that here in Python. So we create the new output node, and that's going to be created as part of the materials node tree, like so. And the next thing we need to do is link them together. And now we want to return that new material back to the user so that it can be assigned as needed. So just as a reminder, as you experiment with the Blender Python API, you can use the console to explore what's available and make sure things are working properly. So let's go ahead and try this out. We're going to create a new material, call it test material, and then we're going to set the use nodes value to true. And we're going to go ahead and clear the nodes in the node tree. And you can see I'm using the tab to kind of automatically complete the lines as I type them. So now let's go ahead and create one of these shaders as well. Okay, so now that we've got this translucent node, let's figure out how to set the color. Actually, here we can see that it's looking for color, and I have in my script base color. So that's going to be a problem. So the principled BSDF has something called base color, but the translucent node only uses color. So let's go ahead and fix that. That'll help us later on. So you can kind of see if you have a problem here in one of your lines, you can easily see what's happening. Because if we tried base color, we can see that that's not going to work. Okay, so that's like just a quick example of how to use the tab completion and the console as you're writing these scripts to interactively debug and troubleshoot what's happening. Okay, so now that we actually have our function, let's use it. So down here at the bottom, we're going to do a couple things. First of all, let's create a translucent material. We're going to go ahead and save that in a variable called translucent matte. And we might as well just name it translucent matte as well. It'll avoid confusion. Like so. Actually, let's just run this quickly to see if it's going to work. Okay, we've got no errors, which is a good sign. And now we want to pass in that translucent material to the lights, add lights function. So let's go ahead and do that. Okay, so let's go ahead and pass in a material as an argument to this function. And we're going to go ahead and use that material down at the bottom. And that's just as simple as taking the mesh object and setting the first material in the material slots list as the new material. So, and that's easier to say. It's actually easier to do it than to say it. So let's go ahead and try it. Okay, so we can see the mesh object has a set of material slots. We're going to take the first one at index 0, and then it has a material, and we're going to set that to be the new material that's passed in here. So if we run the script now, we should hopefully see some of these objects have translucent material and lights inside. Let's give it a try. All right. Starting to look pretty good. And then every time we run it again, we're going to get a different subset of the objects. You can run this a whole bunch of times until you find something you like. And also, if we go down here, let's just say we want a lot more objects to have lights. We can do it like this. Now they're almost all going to have lights. We can have very few objects have lights, which there we just have one. And we can, of course, have all of the objects have lights. And then we get everything illuminated like that. So after trying a whole bunch of these, I settled on 0.2 as the probability. I like the way that that looks. And I also wanted to change the color to something a little bit different. I think it looks nicer with the existing colors. Let's try this. Yeah, this actually looks a lot better to me. So, you know, again, every time you play this, it's going to select a different set of objects to illuminate and keep going until you find one that you like. And just quickly, I want to show you what the rendering looks like. So I'm going to come over here to the rendering tab. I had already done this. The first one in slot 1, I rendered with the Eevee render engine. So you can just set the render engine, go over here to render image. And then in the second slot, I actually rendered one with cycles. So you can see the difference here. Eevee doesn't handle the lighting and reflections very well, and Cycles does a really nice job. So you can see the difference there. So if you're going to do some of these lighting with reflections and indirect bounces, I think for now, going with Cycles will be the way to go. So there you have it. With just a few lines of code and the addition of a new material, we've created a scene where lights shine through the objects, adding a bit of drama to the scene. If you have anything you'd like to see in an upcoming video, just let me know in the comments and I will try my best to cover it. If you enjoy this type of content, please subscribe so you don't miss anything. Hit the like button if you like the video, and stay tuned for more content coming very soon. Thanks for watching.